Hello, everyone, and welcome back. I don't know how many of you have seen my workshop from yesterday. I don't know if there are any familiar faces. If so, welcome back. For everyone that's new as well, of course, welcome. It's good to be back, as I'm very happy to have this opportunity to do this second workshop as well, which is titled "Creating Performant Angular Applications." So as part of this workshop, we're going to take a look at the various aspects of performance in sort of an Angular point of view. And just like yesterday, we're going to follow a very similar pattern whereby I created a few slides just to discuss some of the basic concepts around Angular and performance and some other stuff. And then I'm going to switch to my code editor where I'm going to show you two applications. The first application is, and both of them are Angular applications, of course, but the first one is really terrible, right? It has the worst performance that you've probably ever seen. And the second one has really great performance. And then we're going to compare some bits and pieces from both of them so that you can see what I did to make the app work better. So what I would like you to keep in mind, of course, is both of these applications are just sample applications, right? So I tried to mimic, I think it's like a sports magazine of some sort, like an online magazine of some sort that tries to have an article. So, it's very visual, it has lots of media, but it is just a showcase, right? So I'm going to try to show you some concepts that you can apply to your applications when it comes to trying to increase its performance. But you need to bear in mind that you probably will need to do some additional work in your own projects, but hopefully the things that I'm going to tell you will be a good starting point. So unfortunately, there's no way I can give you, the sort of silver bullet to take and use this, and then your application is going to be the fastest one. You would have to go through several steps and do some work in order to achieve some performance improvements. So let me share my screen. And I think it's this screen that I would like to share with you. So hopefully you are seeing a presentation on the screen which says creating performant Angular applications. Let me know if this is not the case, and I will now go into presentation mode as well. So I didn't introduce myself again, so I do apologize of that. So my name is Tamas. I work as a developer evangelist at a company called Cloudinary. You see my Twitter handle there, and I said that as part of the previous workshop, if you have anything that you would like to discuss, you have any questions about really anything, it doesn't even have to be stuff that we discussed. You want to, talk about something else related to Angular or just, anything related to web development, then feel free to contact me on Twitter. I'd be more than happy to talk to you. Okay, so let's start with this very basic question, right? What is web performance? So web performance, and I think the first point is the most important one, it's subjective. Okay, what you think is fast may be slow for me, and what I think is fast may be slow for you. Okay, so web performance is not an actual metric that you can say. You can't say that, oh, this particular website is fast, because then what do you consider to be fast, right? So web performance is subjective, and web performance is going to change. So the subjectivity further increases if you discuss web performance for desktops, for tablets, for mobile devices. You're going to have different types of mobile devices out there. So web performance is not just one thing that you can sort of quantify. It's going to be a combination of multiple things, including infrastructure, page speed, network connection, etc. So all of those items will impact, either in a positive or in a negative way, how well or how bad a particular site is performing. Okay, you could have a site that performs really well, at least in your opinion, on a desktop on a cabled connection, but when you load the very same page on a mobile phone that's relatively old and has a 3G network connection, you may now think about web performance in a different way, and you may think, okay, this site now no longer performs in a way that you think. Okay, so basically network connection, infrastructure, all of these factors need to be taken into consideration when it comes to talking about web performance. So you also need to remember that you need to embrace the change, right? So 10, 15, 20 years ago, users of a particular site or web page were probably sitting like how I sit in front of a computer, a desktop PC that was plugged into the internet, and they were browsing the internet using that way. Today, we have shifted from these type of people to visitors of your site who are on usually mobile connection, which could be unreliable. They have much smaller devices, so the whole experience needs to change, right? So you need to think about the new ways of how people are consuming your content. And I'm not going to get into the studies, because then this could be an entire day's worth of workshop here. There are lots of studies that say 60% of all internet users are on the internet, and out of that 60, 25% is on 3G, and then the 40% is on 4G, and then yada yada yada, right? You can do that research. I'm not going to get into the details of that, but I'm going to ask you this question. Well, I'm going to answer this question because I can't see what you're writing. But what was the most, or what do you think was the most used mobile network up until 2017? And remember, we're talking about 3 years ago. So what was the mobile network that most of the people who had a mobile phone was on? And when someone asked me this question, I think that was like a year and a half ago, so even closer to 2017. I was sure that the answer is 3G, right? And it's not. It turns out the correct answer is actually 2G. So the majority of the people who were using a mobile phone or a mobile network were on a 2G connection up until 2017. And from 2017 onwards, that has changed to 3G. Okay, it's still not 4G that most people would use, which is very important, because you may have tested your site for a 2G connection or a 3G connection or even a 4G connection, and you said, well, it's kind of slow, but it works. And you never tested for a 2G connection, which would have been the majority of the people trying to access your site. So what I'm trying to say here is that there are two things that you can't assume when you test your application or your website, right? You can't assume that people have 4G LTE or even 5G connections, or even a very stable landline. So you just can't assume that. And equally, you can't assume that people are always buying the latest mobile phones, right? So you can't assume that they purchase the new iPhone every time it comes out, and you can't assume that they purchase the latest Samsung devices as well. Okay, so you need to test using technology that the average people or the mass would use, right? So the average consumer would use. They would be maybe a 3G or a 4G, and they would be on a relatively mid-level mobile device, not on the latest, shiniest Samsung / Huawei / Apple product. I did in fact collect a few stats for you. This is from Google on one of their pages. I think I have the link in the speaker notes. So there are these 4 companies. So Pinterest, I'm sure you have heard of. Cook, this is the travel agent. BBC would be the British broadcasting company in the UK, and then DoubleClick is an advertising company. So Pinterest found that if they have removed the perceived wait time by 40%, and the perceived wait time is a time where users can see that a load is happening. So it's not just a blank screen, you see parts of your screen popping up. And if they reduce that time, that perceived wait time by 40%, they have achieved 15% more signups. If they wouldn't have done that, then they would have lost 15% of people. They wouldn't have signed up. Now, think about Pinterest, and I don't have the exact statistic, but let's say, 100,000 people visit Pinterest per day. Now you would lose 15% of that, which is quite a large number. And I'm sure that more than 100,000 people visit Pinterest today. So Cook, the travel agents, they've reduced the payload by 850 milliseconds. And if you think about 850 milliseconds, that's nothing, right? That's just boom, gone, right? That was 850 milliseconds. So just the reduction of that teeny tiny amount has yielded a 7% conversion increase, 7% of sales converted on their websites. The BBC lost 10% of users for every additional second the site took to load. Again, the BBC is one of the largest websites in the UK for news, for sports, for checking the weather, watching TV shows, all sorts of stuff. Now, if you think about it, what we're saying here is that for every second, they lose 10% of their overall visitor count. Now, I think is BBC is one of the most visited websites in the UK, which means that they just can't afford to lose 10% of the users. And what we're talking about is per second, right? So basically, it's like 10%, 20%, 30%, 40%, and you just keep on losing, right? So they can't afford to do that. So anyway, there are lots of statistics. Basically, the bottom line is if your app performs well, it helps you with conversions, it helps you, with sales, it helps you satisfying your users so that your users will come back to your site because they will know that it loads, they click, they can do stuff. So there's again lots of statistics, lots of research that has been made into how many seconds people try to wait, and it's the 0 to 3 seconds. That's the average time that they want to wait. 3 seconds to 5 seconds, they get a bit itchy, and some percent of your users may leave. And then 5 seconds to 7 seconds, most of your users would leave, etc., etc., etc. Oh, and it's here. I forgot that I put in this slide, but basically it's called the perception of performance delays. So 0 to 16 milliseconds, right? We're not even talking about seconds here. Then we have 0 to 100 milliseconds, 100 to 300 milliseconds. This is the bit where users experience a slight perceptible delay, right? 3 seconds is kind of the maximum that doesn't make people really itchy and think, oh, this is not loading, right? 3 seconds to 10 seconds, that's your window where people, this is like already getting too much. And then 10 seconds or more, users lose focus on the task they are performing. And then above 100 seconds, 10 seconds, users are frustrated and likely to abandon the task, right? So it's bad, right? Anyway, link is there. You can take a look at the additional research that was done in this particular topic. So the bottom line is that, there's this sort of iterative process that you need to sort of remember and try to adhere to this, right? Which is test, measure, and record. So you create a test, and by test I mean, let's take a look at how long does it take to load my site on a 3G network on a 3-year-old Samsung device, right? So that's your test. You then measure it and you say the main page loaded in 3.2 seconds. The the product listing page loaded in 2.8 seconds, and you record these, right? And then you make some changes, and then you test, measure, and record your results again. And then you fine tune, you sort of turn the knobs around, test, measure, record, right? So that's the sort of cycle that you need to go through. Eddie Osmani, who's of the, I think is a developer advocate at Google. Not sure his exact title, but anyway, he works for Google on the performance side of things, I believe, or at least the web side of things. And so, he earlier this year, he tweeted, if you want a fast site, test on slow hardware regularly. Meaning that if you want to achieve good performance, you need to, follow this test, measure, record cycle on a hardware that is not the latest device, as I mentioned, and you need to do this regularly. Okay, and this is how you can, once you have everything recorded, this is how you will see improvements, right? And this is how you can sort of justify the changes in your code that you've done. So when it comes to web performance, your ultimate goal should be and I have a typo in here, I'm sorry. So the ultimate goal is to provide great user experience to the people who are visiting your site, regardless of what device or what network they are utilizing. Okay, so the user experience should be great if a person is using the latest iPhone on a 5G connection, and the user experience should be still great for someone who uses a 3G network and with a 5-year-old Samsung phone, for example. Okay, so your ultimate goal is to create an app that performs well under all conditions, and ideally without a negative impact on the user experience. Okay, so you shouldn't try to make your application faster in a way that is going to have a negative impact on the user's experience. Okay, so you should try to always remember that your user experience, the experience of your user, how they interact with your page, is your priority. Now you may need to, drop a few things from your app, and I'm going to show you an example of that. But that shouldn't be to the cost of, making your site unusable, making your site ugly, so that people, can't really use it. So you have to find this fine balance between these things. And there's a bunch of things that you can do. And this talk is about Angular itself, but still, there's a lot of things that you need to remember. Not just the stuff that is focusing on Angular, because in Angular you can do a bunch of things so that your Angular application is going to be performing better. But there's also the entire infrastructure where your Angular application runs, or the actual content that you're showing with your Angular application. And that is also very, very important to remember. So it's, for every application, and this is true for a React app, a Vue app, a vanilla JavaScript app, for any app on the web, it's not just a matter of trying to make your, preferred framework and recreate the code in a way that it's super good, but you need to think about all the other bits and pieces that make up your application, right? So I collected a few things that, generally speaking, you should be aware of and you should think about, right? So there's backend stuff and there's front-end stuff. So on the backend, you have a server where you serve your application. You should enable compression. You should have HTTP2 or HTTP3 even now. You should utilize CDNs and make sure that you have media optimization in place, especially if your site uses a lot of images and videos, right? You need to make sure that you optimize those. And on the front end, you need to do stuff like lazy loading. You have to do minification. You have to do preloading of your assets. Like you'd have to preload your fonts, for example. And you also need to somehow make sure that the bundle that you create, and this is now kind of relevant to Angular itself, so the bundle that you create has a size that is not disproportionate for what you're trying to achieve. Okay, so there's lots of sort of moving parts, and there's lots of things that you need to think about when it comes to web performance, both in the backend and both in the front end. Okay, so it's not really going to be a demo, more like a let's do this type of call. But as I said, I have prepared two applications for you. One is this one, which I'll try to bring over to this screen here. Okay, so there's this app. We're going to open this application in a minute, but let's just do a, how should I do this? Yeah, let's do an ng build prod. Okay, so let's just build a production build of this app. We will serve it, and then we're going to run a few tests. The reason why I do an ng build is because I would like to, I could have shown you the application using ng serve, but if I do that, then I'm not going to get the right sort of lighthouse scores. I'm not going to get the sort of right results for my tests because I'm using a development HTTP server. So I'm just going to build, a production version of my app and just serve it up using an HTTP server. And that's going to be closer to an actual scenario of you creating an app, building that app, and then trying to serve that app. Okay, so ng build prod, we have all these things ready. So we have the dist folder. And so I'm going to say HTTP. I'm just using the HTTP server from the command line to do dist base. So I'm just going to serve that folder localhost 8080. So let's open Chrome. And let's do localhost 8080. This is not the right app. I'm sorry, I have a progressive web app installed for another thing. Hello again. I'm sorry I got disconnected. Hopefully you can hear me and see me just fine. Need to share my screen again. What was the last thing you heard? I just want to make sure that I didn't skip anything, or I was opening VS Code. Okay, so I did open VS Code. What I did an ng build. Where is it? I did an ng build, a production build of my Angular application. Okay, so you didn't see it, right? So I did a production build of this application, and I was saying that I'm doing this as opposed to doing an ng serve, because I don't want to have a development build and then an HTTP server, because that wouldn't give me the right results. So I'm just assuming that you finished building this app. You're going to build it, make it ready for production. And what I did, I just served it using this HTTP server, right, which is on localhost 8080, right? So this is trying to mimic that you finished development, created the production build, and now you're ready to launch the application. And this is the application here. But let me just do this again, right? So let's see, we're just going to load up this app, which is on localhost 8080. And what I want you to realize is the fact that I'm going to hit enter. And I did it, and I'm not sure how visible that is, but this page, loaded for quite a while, and now I just see the home screen, okay? So this is our application. We have, a sort of welcome screen. We have an about page. This is, a made-up online water sports magazine, and then we have article where we have an article about some game, and we have some pictures, and just as I said, a sample app that we're going to now tear into pieces to see what is happening with it. And the first sort of clue that we get is, if I just again go back to about blank. So if I'm on a blank page, if I do localhost 8080, notice that this is going to load for about 6 seconds, roughly, before I see just the front page of the app, which is already bad. Okay. The Then we have the article page, which gets loaded. But remember, I'm using a relatively good internet connection. There's a question from the audience. Is this a progressive web app? No, it's not. This is not a progressive web app. You could make it a progressive web app if you wanted to, but this example is not a progressive web app. Right, so what you want to do, and that's a very good tool that you can utilize for making sure that your application is performing well, is a tool called Lighthouse. So Lighthouse, it's a separate tool, or it used to be a separate tool, and it got added to the Chrome DevTools a few releases ago, so that you can run Lighthouse reports directly from your browser. Okay, so I'm going to leave these two checkboxes checked: performance and best practices. Like, I want to see what this Lighthouse tool thinks about my performance, what it thinks about best practices. These are just modern web development best practices. And I want to run it against either a mobile or desktop. I'm going to run it against a desktop. Okay, and I'm going to click generate report. So Lighthouse is going to start up, and it is going to, oops. Oh, I know where this is happening. So let's do localhost 80. Go back to this page and run the Lighthouse against this page. Okay, so Lighthouse is warming up. It's gathering information about this page, and it's going to come back to us with a few results. Okay, so performance is a staggering 29 red. That's a big no. That's very bad. And then we have best practices, which is 100, which is fine for this page that only has text. Okay, so performance clearly has a lot of red stuff in here. Time to interactive is 6 seconds. So the time until someone can interact with this page is 6 seconds. So someone has to just sit here and wait for 6 seconds for something to happen. Trust me, if I were to slow this down to a fast 3G, by the way, again, I'm sorry if I'm rushing here. So if you go to the network tab, there should be a drop down that allows you to select a preset that comes as a default in Google Chrome DevTools. You can also add custom ones. So for example, I looked up what the average 4G speed is, and then I hit add, and then you can add those values. Right. So if I change to that, then Chrome is going to throttle the load of this page according to this network selection. Okay. So that's another good thing to use. And of course, you can also check for mobile, for Lighthouse, or desktop, which will then take, I believe, the network speed as well into consideration that you have selected. Now, I would also like to do one more thing, which is going back to here and just do an ng-serve and then run a test against the article page, which will be localhost 4200 in a moment. But even, just the main page has a performance score of like 20 something, that's already an indication to say that something is very wrong. So that compiled successfully. And what I'm going to do now is come back here, go to localhost 4200. Again, notice I have to wait 5 seconds just to see the background. Remember, I'm now on a 4G connection, so things are even worse, but let's just go back online now. I'm going to load articles. I'm going to run a Lighthouse test against the articles page. So let's see how well the article page is going to perform. Remember, that is the main piece of content that I want people to see. I want people to interact. Okay, so 24, best practice is 86. So, really not the best, right? 24 is a really low performance score. 86 for best practices, that's still in the middle range, right? Ideally, you want to be between 90 to 100. So I'm going to keep this short because I think I have like half an hour more to go, if I'm not mistaken. Or is it an hour that I have still left? Sorry, I got confused with the time, but either way, there's a lot that we need to talk about. So what I'm going to do, actually, I think I have an hour more to go, if I'm correct. An hour, perfect. So that's still not going to be enough, but I'll try my best. So the first thing that I want to discuss with you is related to lazy loading. Okay, lazy loading actually means two different things in my book, and I will tell you why. So there are two, and I don't think there's a name for this, but I think there are two types of lazy loadings available, so to speak. One considers the components of your application. You can lazy load your components, meaning that if you are on the home page, you can tell Angular that only load the components that are visible on the home page and not load the article and the about components. So that's one type of lazy loading, right? Component level lazy loading. The other type of lazy loading is applicable to images. Like, for example, here I have, I think, 7 images that you can see here. But if I just load the page, I see 1, 2, 3, and maybe the edge of the 4th one. So there's no need for my application to load all 7 images at the same time, because the user will not see it, right? First of all, they have to scroll down and they have to scroll towards the left to see the rest of the images, right? So that's another type of lazy loading that we have here. Now, the reason why I talk about lazy loading at the component level is because clearly, if I refresh my app, you see that it keeps on loading and loading and loading and loading, and then at some point in time, I get the home screen. But there's nothing in this home screen that should take that much time to load, right? It's just text. There's nothing in here. And if I take a look at the network panel, is it where did that thing go? Sorry, let me just zoom back in for a second because I don't see my stuff here. Yep, right there. And zoom back again. All requests. So if I take a look at the JavaScript that gets requested, I can see that there's the usual. Let's make it bigger. Usual suspects like the polyfills, which is part of Angular, and runtime and other things. And I also get main.js. Okay. There are, ignore this ng validate and backend. These are just Chrome extensions, so I can actually hide those. How do I filter those out? Extension. There's a way that you can hide. What was the flag? Chrome. Okay, I don't remember. There's a way that you can filter out browser extensions versus JavaScript files from your application. There's a question in here. Is the delay in loading because of Angular? Yes. I'll tell you why that is. It's going to be obvious in a second why that is. It's a deliberate mistake that I've done. It's not even a mistake, it's a deliberate thing that I've added to my Angular app just to demonstrate this to you. So clearly you see there is one single main.js file that gets loaded. Then there's vendor, there's script styles, right? So basically there's one big JavaScript bundle that contains the entire Angular application. It's not broken down into sort of components and modules, right? There's one single thing, which means if there's one single JavaScript file, there's no way I can do lazy loading. I can't do lazy loading of my components. And in fact, if I look at the code, source app routing, you will notice that in here, I have, the main page, or the root path, so to speak, which loads the home component. Then I have article, which loads the article component, and I have the path, which loads the about component. So this is not lazy loading. This is just a way to load all your components. And this is where things get really interesting, because when you specify your routing, you essentially import all your components, and Angular will just see all of them. So if in any of the other components you have a task that takes time to finish, that is going to affect every single other component. Okay, and I can tell you what's happening here. What happens here is that I added something to the article component, which takes about 5 seconds to complete, but I should not be affected by that if I am on the home component, yet I am, right? So I'm looking at the home page and it loads for a long time because Angular executes all the JavaScript inside one single bundle, right? Because that's how I set this up. So in other words, I shouldn't be penalized for that 5 second delay on a component that is not even, has nothing to do with the component that is, doing that job, that doing that work in the background. So, you can do some digging around. There's not really an easy way to find this. You would have to know your code, and you would have to take a look at, which component do I think takes a lot of time to process something, okay? In my case, I can show you the article component, because this one is the cause of this issue. And as I said, this is deliberate, okay? So in the article component, I happen to have a Fibonacci number calculation. Why do I have this? Well, this is trying to mimic something that would block the JavaScript process, right? So numerical calculations block the JavaScript process, right? Because JavaScript needs to stop here and it needs to figure out the 40-second Fibonacci number before it can continue on with the code. And as I said, this is just mimicking something. This could be something else. This could be an HTTP request that you're not handling correctly inside the article component. This could be some processing, something that you do inside the articles component that is going to hog the entire JavaScript bundle. And clearly we see that even though this code is only living inside the article component, the home component is affected by it because it takes about 5 to 6 seconds for it to load. This should not be the case. Now, of course, I could just, get rid of this line and then everything will work, but that's not the point, right? The point is, how can I load my home component faster so that the sort of code the Fibonacci number calculation in my article component is going to stay unaffected by it? And the answer to that question is to do lazy loading of my components. Now, Angular is one of those frameworks where you can't really lazy load a component on its own. Okay, in React, you can lazy load a single component. In Vue.js, you can load a single component. In Angular, the way how Angular works is that you have components and then you have modules. So the correct term here is that you can lazy load a module. You need to create a separate module for your article, for your about, for your homepage. And once you do that, you can now lazy load those modules. Questions from the audience. Is this app a single page app? Has the slow loading got something to do with the single page apps? This is a single page application. Even in a I'll keep it simple. This is a single page app, and it's kind of relevant to that because of how I've written this original app, right? There's no module lazy loading happening here. Can we think of it as thread.sleep? Can you think of the Fibonacci number calculation as thread.sleep, if that's your question, Sarah? If it is, you can think of any blocking operation that you want. It can be anything that would stop JavaScript from moving on from that point and having to stuck here to do a calculation, do a processing of some sort. It can be anything. The point is that you have something in here that takes time, that takes 1 second, 2 seconds, and it's affecting other components inside or other modules inside your Angular app, whereas it should not. Okay, so let's fix this. Muhammad, if I'm reading that correctly, what happens if you console this out and you save this, then the page will just load. It's much faster. You see, I'm refreshing, it loads. I'm refreshing, it loads, because there's nothing, this is doing the calculation here, this line right here. Okay, but we can do something else. And let me show you what that something else is. So what you can do, you can create sort of additional components in here. So as opposed to having an app routing module where you have these routes, you can create a separate component for your articles. And you can create separate components for whatever else you want, right? But basically, here the article is just a simple component. Okay, so what I'm going to do, how should I do this? I was trying to figure out, because I won't have time to write all this code here. So what I'll do, I'm going to bring in the final app and I'm just going to show that to you. So the difference here is that I created in this case, I call it articles, okay, but it's the same. So we still have about, articles, and home. We still have the routing module and everything, but the article, and I think Angular properly references this as a feature module, if I'm not mistaken. So this is a feature module. So I created a feature module called articles, which now has its own module definition, and it has its own routing module, and it has its own component. So it's almost like I created, a new module which can have any number of components. And if you do this, you can apply lazy loading. So if I open the article routing module, inside of it, I say, if someone comes to the root of my articles module, I want to load the articles component. Okay, that's pretty much it. This is now a feature module. If you have a feature module, your routing is going to change. Now let me show you the change. And the change is that you can still import your home component and about component. I left those, I didn't touch them. If you have, let's say you have maybe, I don't know, an e-commerce site, right? So you have a products listing, you have a blog section, and you have a customer support section. You could take those and create feature modules of those. You could have a products feature module with its own routing. You could have an articles feature module with its own routing, etc., etc. In my case, again, this is just a sample app. I decided that home component can stay as a component, about component can stay as an about component, but I need to create a feature module for articles because I want to do lazy loading. And in fact, I'm not even importing the articles module in here. I have my root definition, so I have my path for the home page and for the about page. And for the articles, I say if the path is articles, only then, so only if someone hits the article path, I want to import the articles module. So this line here, basically the stuff that I highlighted, is what enables lazy loading inside Angular. So, what is going to be the result of this? The result is going to be that the articles component is only going to be loaded when someone goes to the articles path. Okay, it's not going to be loaded when I'm on the home path. It's not going to be loaded if I'm in the about path. And we can test this now. Let me see if okay, so the Fibonacci calculation is here inside this article component as well. Let me go here, stop this ng-serve, and start up this version of the project. So just to let you know, under normal circumstances in a face-to-face workshop, I would have the base version and we would type in the code and we would make changes, right? But that takes about 4 hours roughly to complete. So that's why I'm just going to switch between the slow version of the app and the new version of the app and just highlight the differences, because that's the only way I can make this faster. So I'm going to serve up the fast application, and we're going to see how how it is different from the other application. And what we will see is that if I load the main page, it's not going to be affected by the Fibonacci calculation inside the articles component. Okay, so let's go ahead and do this. Come on. Right, so localhost 4200. Okay, so we're here on localhost 4200, and you see, even though I have the Fibonacci calculation still in place in the article components, the main page gets loaded. I'm not affected by that calculation inside the article stuff. Now, of course, if I click on article, this is going to take some time, right? Now we got, we have that delay, but this is only affecting this particular article, this particular component is not affecting my entire application. And also, if you take a look at the files that get loaded, notice that this is now, and I forgot to say that the main.js I think was around 40 something kilobyte. Now main.js is only 24 because this only contains the code for the home component. And if I clear this and if I click on article, notice that now a new JavaScript file gets loaded, and this is the code. Anyway, it's articles module.js. This is now the code that Angular needs to load this particular page. If I click on about, sorry, that's part of main.js as well. Okay, right, so I have this separate loading mechanism in place now. Is lazy loading here done via Angular or Webpack? So it's done at the Angular level. Where is it? It's done at the Angular level, but I'm sure Angular under the hood utilizes Webpack as well. But I'm doing it only at the Angular level. I haven't done anything whatsoever. Okay, I just created a feature module called articles with its own routing, its own components, and I just then added this load children, and then I imported the module this way. That's the only thing, the only two things I've done. I haven't touched any Webpack config or any Angular configuration. I haven't done any of that. So hopefully you now see the difference, right, between these two types of applications. Now, of course, the problem still persists. I mean, it's not really a problem because it was deliberately done that the article page loads for about 5 seconds. Okay, but now, once you figured out that the problem is with this particular component, you can then take a look at this one and figure out why it's taking a bit more time to load than the others. Okay, in my case, as I said, for demonstration and educational purposes, it was because I used that Fibonacci calculation. Okay, now, so that's lazy loading of modules. Okay, we're going to come back to lazy loading as well, but this was lazy loading of modules, and if you're interested in this, you can further research this by taking a look at feature modules in Angular. So that's one thing, right? So let's stop this app and go back to our sort of faulty application, which is right here. So that was one thing, right? That's we kind of checked off from the list, which is try to lazy load your Angular modules if you can. And not if you can, but it makes sense to create these feature modules and then lazy load them, as opposed to load all your modules or all your components at the same time in one single bundle. Okay, so I'm going to get rid of this console log statement just to fasten things up. And the next thing that I want to talk to you is something interesting as well. So, you keep on developing your Angular application, and often what I find is that I install a package, I then decide not to use it, and there are cases when I, figured out a feature that I wanted to add to my app. I then kind of retracted on that, maybe uninstalled the package, or I didn't uninstall the package, but there may be some leftovers in your code, references to packages that you're not using at all, and you've completely forgotten about them. Now, what you can do in Angular is open your Angular JSON file, which comes by default with every Angular project that you start. And in this file, look for two parameters, which is, where is it? It's not even parameters, so two properties. I will just search for it. Source map. Okay, so you can set source map to true and named chunks to true if those are set to false. I was trying to remember, I think by default these are false, if I'm not mistaken. But basically what these allow you to do is to run some sort of diagnostics with your Angular application. Okay, so you have to set this to be true, because then you can, with a tool that I'm just going to show you in a moment, you can extract valuable information from this project. So what you do an ng build, create a build of your Angular application. Once it's complete, you then can utilize this tool, which is called Source Map Explorer. Okay, Source Map Explorer allows you to sort of analyze and debug your JavaScript bundles. Now, there are a lot of such tools. Okay, so there's a lot of similar tools to this, but the Angular team actually recommends that you use this one. So the tool is called Source. Let me just type it in. Source-map.explorer. Okay, that's the name of the tool. It is installable via npm, so you need to do npm i-g source map explorer to install this particular tool. Okay, now what you can do, so if I go to my dist folder, so cd dist base, yeah, so we have these files here, and what you can do now is source map explorer, and you can explore your JavaScript file with it. So you specify the file that you want to explore, and the correct source map. Your source map first generated comes in line 22 by 72 columns. Okay, let's do second source. Okay, so there's an ng build prod. Right, source map. There. Oh, so yeah, under production. Okay, I need to do production. Sorry. So the two values that you want to do is source map and name. Oops, and named chunks. Okay, set those to true, and the combination of these two will allow you to use this tool, which hopefully is now going to work. If not, then I have a small issue here. But let's see. Okay, so cd into dist base and source map main.js. Oh no, it's right here. Oh, I know what was wrong. I'm sorry. So I should have run ng build prod at the first place. I just did an ng build. And the reason why we have these values is because, of course, now we have the appropriate source map files as well, which we asked explicitly via the Angular CLI, right? So now I can do source map explorer main.hash.js. So hopefully this is now going to work. Perfect. So what this brings up is a browser window, and it shows you this automatically. It basically shows you all the packages that you are using. Okay, so it shows you that you're using the core package, you're using the router, you're using the platform browser, you're using animations, and if you're using packages so if you see a package here, let me reiterate. So if you see a package here that doesn't make, like, you don't remember using it, and one example could be the Angular HTTP package. So I could demo that to you real quick. So we could go into a component, and I could import the HTTP package in here. If I do that, that's going to show up as a package that I use. But then we realize that we're not actually using it, right? So if I go to module, oh, it's actually here. Sorry, HTTP client module. So we should be able to see it here. Where did that window go? Why don't I see? Where is it? Angular, router core animation. It's not in animations, is it? Wait, I'm at the right project. I'm using the HTTP client module. I'm importing it. So this is something that I've done deliberately. Like, I added this HTTP client module, but I'm not using HTTP requests in this application whatsoever. And I think I also added the browser animations module, but I'm not using that at all either. Now, one of those shows up in the source map explorer. What if I do, let's try scripts as well, but I don't think it's in scripts. This is for external scripts. So Bootstrap, jQuery, I'm using both of them, but there could be, again, something that you installed, something that you use in Angular, and now you would want to, make sure that you're not using it. So you need to do source map explorer main 67, main.67.js. Okay, well, let me see if I can check HTTP. Oh, there it is. I'm sorry, when I zoomed in, it got lost. Is it zooming in like this? Can you see my screen being zoomed? I'm not sure if you do, but basically in the bottom, there is HTTP taking up 14 kilobytes. Okay, so I can't zoom in using the browser, but so there's the HTTP package, which I'm not using, and as this, so it takes 14 kilobytes, not a lot, but still. Then I have the animations package, which takes up 64.43 kilobytes, so 21.8% of my overall bundle is animations. I'm not using animations. I'm not using HTTP. Why do I need them? I don't, right? So this tool helps me to sort of map out all the JavaScript files, all the modules that I'm using. Some I may have used and no longer use. Again, for this, you need to know your application, right? You need to know what you're using in your application. So if you open main.js, you will see the Angular specific dependencies. If you do script.js, you will see any sort of third-party JavaScript files and modules and libraries that got loaded. So the overall bundle size is 295 kilobytes. So that's 100% of that, right? So 295 kilobytes. What I want to do is get rid of HTTP, get rid of animations, which should reduce that size by roughly 100 kilobytes. Okay, so let's actually do that. So what I'm going to do is, of course, I'm not going to import the browser animations module because I know I'm not using it. And I don't want to have the HTTP client module either because I'm not using that either. And save this. I need to rebuild a production build. Okay, so you need to always, build. What is going on? Okay. Production build at the right place, of course. So, once the production build is built, you can then re-examine your bundle using the source map explorer. And hopefully we will now get So we had what, 230 something kilobytes. We should get around like 170 kilobytes in the overall bundle size. Again, this is a workshop. This is just for you to think about your application. This is not a massive save. At a larger app where maybe multiple people were working on the app, you could find some dependencies, some leftovers that could be 500 kilobytes in size, and you can now just very easily get rid of them. There's a question. Interesting that Source Map Explorer can show unused packages. Can we use ESLint or similar? I'm sorry, I don't get that question. So are you asking if you can use ESLint to sort of show you the unused packages before, like you're looking for a way to show unused packages, if I reckon correctly. So Source Map Explorer it shows you what you have. Okay, it shows you what you have added to it. It can't really tell you whether that's actually needed or not. It's just going to show you these are the things that you use. You would have to know whether you actually use them or not. That's what Source Map Explorer allows you to do. Remember, you need to make the change in angular.json. You need to say source map true. Otherwise, the Source Map Explorer will not work if you don't have source maps. So this base main, yes. Right, so, okay, so the overall size did go down, not by as much as I was hoping, but still we went down from 200 and I forgot what it was, but now it's much less, and I no longer see the HTTP nor the browser animations module because I was not using those. I was not using those anyway. Okay, so what I see now is just truly the bundles that I use. Okay, so this tool, you can use this tool just to explore what stuff you have in your Angular app and then try to get rid of the stuff that you don't need. Okay. So going back to the base application, right? So we talked about module loading. We talked about Source Map Explorer. Okay. So we have 30 minutes to go. Right. So let's talk about another type of lazy loading. And in fact, let's just talk about media in general, right? So most of the web pages, or the heaviest component of a web page, is usually the media, right? Images, videos. Those can be quite large. They can take a lot of time to load, especially if there's a video. And we do have a video. Where did the application go? I need to load this again. So we do have a video right here. Okay, so there's a video, there's images, and the web is media heavy, right? So we live in the age of a visual web where people are actually looking for visual content, e-commerce websites trying to show you 360-degree videos of their product, high definition images, so that you are going to buy those, trying to push you to sort of buy those products. So there's no denying in the fact that anything on the web that we have is visual. Now the problem with that is this particular page has a lot of media, and as you can see, there's 41 megabytes just on this page, right? 41 megabytes worth of stuff. And if I select images, the images on this page take up 36.8 megabytes. That's a lot. And you wouldn't even think, right, that this whole page is 41 megabytes because I refresh and it loads. But I do have a fast internet connection. So let's see what happens if I want to load this page on an average 4G connection. Okay, let's try to see what happens, right? So now I am mimicking a mobile connection. Okay, well, I'm not sure whether this is a video, but it's kind of playing. Like every second I see a frame of it. That's not really good experience. And then these images got loaded. And this is 4G. Let's do fast 3G, which is, again, getting closer to what the average population would have access to. So this is what happens when someone loads my sports magazine on a 3G, on a fast 3G connection. Okay, hopefully you get the idea, right? This is not good. This is already beyond acceptable, right? The background loads in about 10, 15 seconds, and I don't even see any content. So now content starts to come in. So there's some images that get loaded. Also notice the text. I lost all my fonts, right? So the fonts are not the correct fonts that we were seeing before. That's going to be an important thing that we're going to come back to. These are different fonts. My images are still, some of them loaded halfway through. Some of them are still loading. The video is not playing. It's just wrong. Okay, I wouldn't even dare to run this page through now Lighthouse because it would just give us a very, very low score, both in best practices and both in a performance score. So what can we do to optimize this, right? And I just want you to see that the font is going to change in a moment, or at least I think once the images get loaded, I think the font will also load, or maybe not. It will load eventually. I'm just not sure what the actual time frame for that would be. But we're going to talk about the font as well. Basically, the browser is prioritizing between assets, and it decided that the font can wait. It needs to download the video and the images first. And in fact, images are kind of downloaded. Okay, and now the font has updated just like that. Okay, not good. And my video is still not playing. Well, it's playing kind of like half. The board just moves a little bit. Okay, but it's bad. Okay, right. So this is how it should look like when I'm online. It's like a 15 seconds worth of video. So let's talk about images, videos, and media in general on the web because it's an important topic. So what you have here is, in fact, me cheating again. This is, you think it's a video, it's not. It's a GIF. Now, I can't see you. I don't know if you're smiling or you're like shocked, but essentially, a lot of people still think that GIFs should be used as videos on the web to show visual animated content. It's not good. You saw it why it's not good. And I can tell you that this single file here, just that GIF, takes up 18.4 megabytes of the entire page, and the JPEGs that I'm loading are each about let's see, 1.1 megabytes, 3.4 megabytes, 1.7, 1.9, 2.7 megabytes. All these images in the image gallery are larger than 1 megabyte in general. Some of them are 2 or 3 megabytes in size. Okay, that's not good. So there's no image optimization taken in place on this particular page. Also, the author image, if I do a copy image address, and if I want to open this image, this is the size of that image. It's 2,134 pixels by 3,200. What happens here is that that image gets shrinked down using CSS, okay, to be 100, if I can find it to you here. So the size of it is being shrunk down to 100 times 100 width and height. but it's done in the client. Okay, this is how the image would look like if I wouldn't apply CSS to it. The problem with this is that this image here, called an author, that image is 1.4 megabytes in size. Again, terrible, right? So what can you do about this? So when it comes to images and videos on the web, there are different file formats and there are different optimization techniques that you can take a look at. So for example, Chrome supports the image format that is called a WebP. Okay, WebP images are the best images that you can serve for a Chrome web browser. However, you generate a WebP image, it literally has a .webp extension, you try to serve that image up in Safari, Safari will not display that image because it doesn't know what a WebP image is. But Safari says, you can give me JPEG. In fact, you should give me a JPEG 2000, which is one of the latest versions of the JPEG spec, and that's the best image format that I can work with. Same is true for videos. Chrome says, give me a WebM, which is short for web movie or web movie. You try to open a WebM file in Safari, Safari says, I don't know what this is, give me an MP4. So different file formats for different browsers. Ideally, for one single image or media asset, you would have to create all these various versions and try to serve that up for the requesting browser. So there's a lot of logic that you have to put into place. Or, as an alternative, you could use a solution that does exactly that. So we can, and we will in fact, change this page and do a few things. First of all, we're going to optimize the video. We're going to do image lazy loading for these images, and we're going to fix all the other image issues, starting maybe from this profile image. So what you want to do here is you want to have the face of the author, of the person who has created this particular piece, this content piece, right? You want to have a zoom in on the face, a typical profile picture. So what you can do, and in fact, what I've done in the in this final application is I'm using the service Cloudinary, which is the company that I work for, right? Because this is what we do. We do image management inside the in the cloud, and we do optimize these images. We allow you to consume these images using the using our services. So what I'm going to do is show you this one thing. Oops, here. So what I've done earlier to this workshop is I've taken the images from this particular project and I uploaded it to a Cloudinary account, which is free, by the way, right? So there's a free tier that you can use and get started. When you upload an image to Cloudinary, what you get back is a URL that looks like this, right? So it's something cloudinary.com, my username, image upload, web-perf, which is just a folder that I created inside my Cloudinary account, and then author.jpg. And in fact, if I log into my Cloudinary account, probably it makes more sense if you see what I'm actually talking about. So I can log in. I have this media library folder here where I have all my images and videos that I ever uploaded to Cloudinary, and there's a web performance folder. And inside this folder, I have all the images and other stuff that I'm going to be using for this project, including this wonderful lady who it's a stock image that I downloaded, who's going to be my author. So if I open the network panel, we established that this image, doesn't matter if it comes from Cloudinary or not, the size of it is 1.4 megabytes. Massive, massive file size, right? So 1.4 megabytes, because first of all, it's a JPEG image and it's 2000 by 3200 pixels in size. So what can I do? Well, I can first of all change the width and height of this image by adding width w underscore what's the size that we need 100, comma height underscore 100. Oops, wrong place. I need to do it before the folder, like so. What happens now is I get an image generated on the server side delivered to my browser, which is only 100 times 100 in size. And we have reduced the size to be 6.7 kilobytes. 1.9 megabytes, 6.7 kilobytes, just by reducing the dimensions. But this is, I'm still not happy with this. It's too large, trust me. 6.7 kilobytes, no, too big. So what can I do? Remember I said something about WebP. This is a JPEG. I'm in Chrome. So how can I make sure that I return a WebP? I'm going to use another flag called f_auto, which is short for automatic formatting. And what Cloudinary will do now, it will load this image and it will take a look at your browser. If the browser is Chrome, it will load a WebP image. If your browser is Safari, it will load a JPEG 2000 image. If it's, Firefox, it will load probably a JPEG or maybe a WebP as well. So fauto is going to further reduce my size. So 6.7 kilobytes now. We went down to 6.5 kilobytes. And if I look at, okay, wait. Let's do it without the size restriction. So let's just do just an fauto on the original image. So even from 1.4 megabytes, it went down to 940 kilobytes. And if I take a look at the headers, I get a WebP returned to me. It's no longer a JPEG, it's a WebP. If I take exactly the same URL, and if I go to Safari, open this image up in Safari, go to the network panel in Safari, and just refresh, and take a look at the headers, I get image JPEG 2000. So JP2 is the content type for image JPEG 2000. This is done 100% automatically for me. I didn't need to do anything, right? I can also do one more thing, right? So 1.4 megabytes to 900 kilobytes, I can do qauto as well. This is automatic quality. Cloudinary will contextually examine the image and it's going to remove all the pixels that are not needed for us to see. So it's going to reduce the quality of the image in a way that it's not visible to the human eye. So the image, if you take a look at it, is still very large, but the quality of the image is still very good, right? I mean, I don't know how much that comes across my screen, but it's real good. But the size is now just 656 kilobytes, right? So 1.4 megabytes to 900 kilobytes to 656 kilobytes. Now I can apply the width 100, height 100, and I get an image that is 2.9 kilobytes. And I can do 2 more options. Crop me a thumbnail and find the face of the person automatically and create the crop of 100 by 100, focusing on the face. So the face should be in the middle. And this is my result, 2.6 kilobytes for the profile image that I wanted to have. I could even do a radius. I could do a comma radius underscore max to make it round, which brings up the size a little bit to 3.6 kilobytes. 3.6 kilobytes instead of 1.4 megabytes. This is a massive reduction in quality. I could also do just one more thing, DPR underscore auto, that's device pixel ratio, meaning if someone is looking at a retina screen, I want to see a really good quality image. If someone looks at a standard screen, then I want to show a 1 pixel count for them. So now I still have 3.4. I could go up to DPR 2.0, 2 times amount of pixels. So I'm going to get sort of higher quality at the expense of sort of doubling the size. But the point is, I'm still in the 1-digit kilobyte space as opposed to the megabyte space. So that's one thing that you can do that's going to fix the issue for the author. Now, I don't have time to go into the rest, but basically what I've done, I added fauto, QAuto and a width restriction to all of these images using Cloudinary, and that will help us to reduce the overall size of this page from 41 megabytes to about 1 megabyte. Let's talk about this GIF as well. So first of all, if there's one thing that you will take away from this workshop, is to never ever add GIFs to your web app. Never ever add GIFs to your web app, please. Okay, it makes no sense. Why? First of all, this GIF is what was it, 14 megabytes? So it's like many megabytes in size. You shouldn't do that. What you can do, and in fact what I've done, is I uploaded this GIF to Cloudinary, changed just the extension, because you can do that, to an MP4, and you can now embed this as a video. So what I'll do, and I think because in the sake of time, I'm going to open this base app, close this, and come to the final solution, because I need to wrap in like 10 minutes. So what I've done, I created an MP4 file out of that GIF just by, you can change any extension in Cloudinary and it will work. So instead of a GIF, I add a video element, and if you add autoplay, muted, and loop to any video element as attributes, you will have exactly a GIF-like feature, because you will autoplay it, you will loop the video, but it's going to be much more performant. So if I do an ng-serve, if I load this particular articles page for you now, you will not see the difference, and you will not be able to tell whether I'm using a video or a GIF. It would just be content, animated content that will play. Okay, so if I go to localhost 4200 now, click on article. Oh, and I left in the, hang on. I need to get rid of my Fibonacci thing. Okay, so if I come to the article page, see, you can't tell me whether this is a GIF or not, but the overall page size with all the images optimized is 5 megabytes. I'm sorry, so it's 5 megabytes with all the video, all the image data and everything, as opposed to 41 megabytes. That's a massive save right there. Then I've also done lazy loading, and there's a bunch of ways that you can do lazy loading. And I'm sorry for rushing, but I want to teach you as much as I can. So the way you can do lazy loading is option 1, you can write it on your own. Option 2, you can use something like Cloudinary. We do have an SDK for Angular, and inside the image gallery, I use the Cloudinary image component that comes as part of our SDK, which has a lazy loading option. So if the image is outside of your viewport, in other words, if the image is not visible to the user and to the browser, it will be loaded at a later point in time. Your third option is that you can use a third-party lazy loading library like Lazy Sizes to achieve lazy loading, right? So there are 3 ways that you can do lazy loading. Because I uploaded all the pictures that I have to Cloudinary and our SDK supports lazy loading, I'm just benefiting from that. So how does lazy loading work? What I would like you to do is to pay attention to all these images. I'm just going to prove this to you using the network panel. So we have 7 images there, right? They all start with, where are they? I think it's called image 1, VP dash, yes, VP dash 1, 2, 3, 4. So there are 7. But if I first load the page, and I want you to see this, I'm trying to, maybe I need to shrink down my screen just a bit. So when I first load the page, I'm filtering for these VP images as 1, 2, 3, and 4 that get loaded, because remember, I only see 1, 2, 3, and 4 images. If I scroll, if I start to scroll, come on, scroll. If I keep on scrolling, notice that 5 got loaded now, 6 gets loaded, and 7 also gets loaded. So the images only load when they actually will move to the viewport. Okay, this is also saving me a bunch of kilobytes or maybe a megabyte because I'm not showing all the images for my users on the page. One more thing that I added, because remember what I said, I want you to think about performance in a way that it's not going to restrict your user's experience. You still want to give a good user experience to user without a negative side effect, without trying to give them or showing them a negative impact or giving them a negative impact. So how can you do that? Well, this page, and that's why I choose this example, because this page has, really nice graphics. It's like a visual experience to your users, right? There's a video, there's text, there's pictures. But what if they, fire up this site on a mobile on a 3G connection? The video is still better than a GIF, but this video will take some time to load on a mobile. So to sort of circumvent that, what I've done, and to give them a good experience, is that I have, it's not in here, it's in the TypeScript file. What I've done a little trick, and I'm using this thing called the Network Connection API, which is one of the latest web APIs that you can access, which basically has this property called effective type, which gives you the connection type of your user. And it has values like slow 2G, 2G, 3G, 4G. Okay, 4G being the fastest connection, 3G slower 2G, slow 2G, the most slow connection. This is a new API, so you have to check if the API exists via these checks to make sure that they are actually there. There's a way around this, which I'm going to tell you in a minute. But what I do, I say if they are on a 4G, I say fast connection is true. If they are on a 3G, I say that fast connection is false. So, there's a sort of switch that I'm flipping. And if I go to the component, I basically say, if they are on a fast connection, show the video. If they are not on a fast connection or else, only show an image from that video. Now, how do I generate an image from a video? Well, let me show you. I'm using Cloudinary. I have the MP4 file, which is playing the video. If I just change this extension to JPEG, I now have a JPEG image. This is a still image, and it happens to be the middle frame of the image, which is just when this guy is doing his shot. So in other words, what I'm doing in my code is that if someone is in a 3G connection, which we will test now, they will still have a visual experience, but it's going to be geared towards their needs, right? So what's going to happen here is that they will just see an image being loaded on this page, okay? Now, the reason why this is still slow, remember, I'm using a development build. I'm not using the production build yet. But what you should see, that you should see all the text appearing on this page in any second now. And instead of the video, you're just going to get a still image. This still gives your users a visual experience, and they don't need to download potentially that large video. One more thing that I want to show you, and then I unfortunately need to wrap, and I'm sorry for rushing through this, which was the font preloading. There is this preload thing that you can do. You can effectively poke the browser and say, when you download your resources, the browser prioritizes on its own. It will say, I will download fonts later. I'm going to download the image now. I'm going to download the text and parse the HTML and JavaScript, etc. With the rel preload attribute, you're telling the browser that these two fonts are important because you want to make sure that the font type or the font family gets loaded straight away, right? That your text doesn't flicker, your text will not update at a later point in time to have a different font. it will be loaded straight on. So putting all of these together, so I'm going to do an ng build -- prod. And I also created a server, like a Node.js server, which does HTTPS, which does compression, which uses HTTP2 to serve up this application. And we're going to see the lighthouse code for this latest application. Okay, so we're going to see how well it's performing compared to the base that we showed, right? The base had what, a score of like 29, if I remember correctly, with a best practice score of 82 and 100 for another case. So let's see if this application is going to be better. Hopefully you already expect this to be better, but let's just see what happens. So let's do node server.js. Oh, I forgot to add the server keys to this project. Okay, let's just do an HTTP server for this and final. Localhost 8080, so localhost 8080. So this is on a 3G connection, right? So on a fast 3G connection, still my font is there. That's a debug I added. I'm sorry, I forgot to remove that. Images are there. The page loaded relatively quick, right? I mean, this is a 3G connection for the oh, come on. For the article. Okay, so article, and even though it's full of, media assets and stuff, I can still, start to read. I have a visual experience. So still, I have an Angular app that performs really well. If I were to use, so let's do a test against this using Lighthouse, but I don't think this is going to work because we got a 404, unfortunately. If I can take 5 more minutes, then I will just bring over those keys that I forgot to copy over from. Oh, actually, no, those are gone because I deleted. Oh, never mind. I'm sorry. I deleted the files that I should not have deleted. So basically, in order to have HTTP2, you need to have server keys, and I mistakenly deleted those from this project. So we can't have HTTP2, but instead we could, let me try to think. Options, I could get rid of the options maybe, and then try to see if that's going to work. I'm not sure. Let's see if I just get rid of this part here. Node server.js. Yeah, that's not going to work. Speedy requires options, probably. Anyway, there's one last thing that I want to show you, which is, let's do ng serve. But there's one more thing that you can do when it comes to checking unused code, as opposed to just using source map explorer. There's another way that you can check for code that you may not use inside your app, and that comes part of Lighthouse as well. Not Lighthouse, sorry, DevTools. Okay, so if you go to this little 3-dot icon here, and then you go to more tools, and from more tools, you find the option that says coverage. And then you, as it says, click the reload button. So we're going to click that reload button. This coverage is going to tell you what lines you're using from your overall JavaScript files. Okay, so you can actually take a look at this. And this is probably better done in development, but basically you get this particular report that says you're using 40% of your overall, but you're not using 40% of your overall bundle, and it also highlights it to you in your code. What are the statements that you're not using? They're highlighted by red. But this is, of course, now uses your overall bundle, so it's very difficult to just say what is actually being used and what not. In development, this could be much easier, right? So here I have scripts out of the jQuery. I don't think I'm using any of that, right? So I'm not really using jQuery. And here it's only added because of Bootstrap. So this way, and you can run the same for CSS as well. I'm not sure why I don't see CSS now in here, but if you have large CSS bundles, this tool will also tell you how much of your CSS you're using. And what's great about this as well is the fact that you can, where did I put it? Is it in source? Maybe I forgot to copy that over as well, unfortunately. So there's a way that you can programmatically check for this as well. I thought I had this additional JavaScript file in here, but I can't find it. So there's a way that you can programmatically run coverage tests as well. There's an NPM package for this produced by Google. One caveat that I want you to remember is that once you run this coverage test, remember that these coverage tests are on a per page basis. So it may be that I'm not using this function on this page, but some other page may be depending on this particular function. So just remember that, okay? It helps you to have a general understanding of what functions are used and not being used, but remember, this is not per page basis, okay? It's just, again, something for you to explore, something for you to take a look at, try to, highlight maybe bits and pieces of your code that shouldn't be there, you should move it. You can play around with this as well. So again, it's the 3 dots here, more tools, and this tool is called the coverage tool. Okay, and if you run a lighthouse report against the article page, just as a last thing to do, as I said, it will still complain about a few bits and pieces about the server because I'm not running HTTPS, I'm not running HTTP2, etc., etc. But hopefully, the performance went up for a development bundle. Still, if you run this on an HTTP server, so on a full-blown HTTP server, which I would still love to do, let's get rid of this PD component because I really want you to see that pd.create server. So maybe it's just app.listen. Okay, let's try it this way. Node server.js 8080. This is now going to work. Articles. Okay, so let's do a test against this site now. So this is running an HTTP server, still not HTTP2, but here we go. Performance 97 of our latest production build running on a proper HTTP server, as opposed to a 29 that we got when we started. Okay, there are still some issues that you can take a look at, mostly related to image elements and some other bits and pieces for not using HTTPS, but generally speaking, we are now in a good place. Okay, and to wrap up, let's go back to my slides. I collected a few resources, things that you can take a look at and read and play around with when it comes to web performance. The links are there for both of these projects. They are available on GitHub. So the base app, which is the slow app, you can compare it to the fast app. So there's 2 different repositories that you can take a look at. And with that, yesterday I managed to remember this. I think it was mashallah and shukran, if I'm correct. So thank you very much for your patience, and I hope you enjoyed this workshop. It was a pleasure to deliver this to you. And as I said, if I just go back to the very first slide, should you have any questions, then feel free to contact me on Twitter. I'll be more than happy to discuss anything with you. If you have links to share, I can copy paste them on the chat. What I'll do, I'll share the presentation with you, and then you can distribute it to the attendees. That way they will have access to both the links and to the presentation, if that works for you. Okay, cool. So again, thank you very much. Hope you had fun, and have a great rest of your Sunday.